have logical operations, we have example of some values. So here we have y, 0 is false, 1 is true, and z is same in the same way, but we have a combination of them. So that is false, false, basically. This is false, true. This is true, false, and this is true and true. So here you're gonna see the different logical operations that we can have. So if, for example, we talked about and or, for and you need both of them to be true, so you only get here to get true. For or, one of them if it's true, you're gonna get a true. And then you have different combinations that, for example, here you have it's kind of like not and not or. So these are like the opposite of those. Or you have X or, that means either this or that, but not both. So these are the combinations. And in MIPS also, you're gonna have this instruction for this. So here you see basically a not that literally if you have a number, it's gonna basically do the flip that we talked about. So if this is your number, it's gonna flip every bit. So it's gonna do the not operation on every bit that is on that variable. Here we have the different examples that we have, like different operators that we saw on that table. So we have and, or, and nor, and so on. And these are the examples. So it's basically, the only trick here is that the operation gonna be ran in each pair of bits, basically. So it's gonna be executed on each pair if you are doing, for example, two variables together. So this 0 and 1 gonna be here we are doing XOR together, and you're gonna get the result. So for each of them gonna be executed, and then you get the number, and then of course it's converted to hex at the end. Here we have a shift operation. So you have this actually in most languages, in C++ or C. Basically, you can shift all the bits by a specific amount. So what does that mean? Like, for example, here, that if we have the number here, and there's 4 ones, and if you are shifting by 3, so you are doing shift logical left, and this thing, S1, you are shifting this by 3 to the left, and you're storing the value in S0. So your first bit gonna be here. The second one gonna be the next place, and so on. So basically, you're moving everything by 3. And then the last one, of course, this 3 is gonna be erased, kind of. So it's not gonna be part of this new variable or new number. And on this side, you're always gonna get zeros. So that's how the shift logical left works. If you are working with right shifts, so that is the shift logical right. It's the same thing, but it's basically the direction is different. So everything is going to the right, and so this one is coming in this position. So everything is moving 3 to the right. And on the left, that the 3 new space that you're gonna have, you basically is filled with 0. So that's the shift right logical. And then we have one more that is basically the arithmetic shift. And that one is only for right, and it's gonna look at the sign. So when you are doing your shift, if you have a 1 here, that means your number was negative. So instead of filling this with 0, it's gonna fill it with 1. If you had a 0 here, it would be the same because it's gonna be filled with 0. So that's the only difference between the shift right arithmetic and shift right logical. It's just a sign bit that is different. And then there is another idea that, and you can easily prove it in math, that basically when you're doing shift to the left, it's equivalent of multiplying your number by 2 to the n, and n is being the amount of the bits that you're shifting your number. So for example, if you had, let's say, do a very simple example. So if you have 0 1 0 1, so this number is actually, we have here 2 to the 2, so 0 1 2, so that's 4 plus 1, and that's 5. If I shift this, let's say by 2, so let's say I have more zeros here, I have space, and I'm shifting it to the left by 2. So by 2, I'm going to the left. So I will have basically 2 zeros, right? And then I'm gonna have this 1 0 1, and then 0 0. So if you calculate this one now, this is gonna be 2 to the, so 0 1 2 3 4, right? So it's gonna be 2 to the 4 plus 2 to the 2. So that's going to be 16 plus 4, which is 20. So this here, it says when you are shifting by 2, basically you are multiplying your number by 2 to the power of n. So in our case, it's 2 to the power of 2, which is 4. So we are multiplying our number by 4. And it looks right. So because 4 times 5 is actually 20, right? So this is times 4. And you see that. And it's very easy to see why this holds true, because here we had, like, if I want to write this as sums, this number was 2, the one on the top is 2 to the, this is 0 1 2, right? This is 2 to the 2 plus 2 to 0. So if I shift everything by 2 to the left, that means now this one is going to be 2 to the 2, and this is going to be 2 to the 4, right? So each of these is as if each of these I times by 2 to the 2. So they added. So this 2 added with this 2, it comes to the 4. This is 2 to the 0 plus 2 to the 2. So this, the signs added, and that's 2 to the 2. So basically, the value of each time that is moving, it's as if they are being times by 2. So the same thing is valid if you are moving the other direction. It's basically the division to the 2 to the power of amount of the bits that you are shifting.